Hi, this is Carla Brigandi, and today we are doing Lesson 5, Debugging with Laurel, Course D. Again, the purpose of this video is to demonstrate how to find Lesson 5 in Course D, to model pedagogical strategies for implementing Lesson 5 Course D with your students, and again, to review computational thinking concepts and powerful ideas that are specifically aligned with Lesson 5 in Course D. There are 3 lessons of the 16 amazing lessons in Course D that we're asking you to do with your students, and those include Lesson 3, Introduction to Online Puzzles. Today we're going to do Lesson 5, Debugging with Laurel, and next we'll be doing Lesson 8, Dance Party. Just a reminder that computational thinking is the mental skill to apply fundamental concepts and reasoning, so we want to really reinforce those fundamental concepts, and we want to teach our students how to reason. These are derived from computing and computer science, but honestly, these are great tips and tricks that can be applied to all academic areas and also to life. These computational thinking concepts and powerful ideas, the ones that we're reinforcing today, include decomposition, taking a big problem and breaking it down into more manageable steps. A bug, sometimes what we do doesn't really work out, and that's not an issue. We just simply have to debug it. We find the problem and we fix it. A loop is something that happens over and over again. So are there specific actions that are happening in a pattern? Algorithm, a list of steps to finish a task. Remember that if we have an algorithm for life, get up, go to eat your breakfast, get dressed, go to school, that's an algorithm. It's a list of steps for what we do every day when we wake up. In order for that algorithm to be a program, it's an algorithm specifically designed to be run by a machine. And when we write an algorithm that can be run by a machine, we are programmers. There's also some awesome critical thinking skills that we're going to implement, demonstrate, or have students use during our lesson today. They're going to compare and contrast, cause and effect. They're going to plan, predict, new today observation, problem solve, sequence, and recognize patterns. We're also going to be using some pedagogical strategies to help our students master this content. We are going to give them time to play, to think, and to code without directly instructing them. We are going to provide a direct formative instruction. We're also going to use the PRIM approach. We're going to predict, run, investigate. Students will modify, they'll make a program, and students will problem solve. We're going to teach them to understand the problem. So rather than having the students jump right in, have them read what the instructions say, have them come up with a plan, and then have them turn that plan into an action. Next, I'm going to show you how to find the lesson, and then I'm going to demonstrate some things that you can do with the lesson. So now I'm going to show you how to locate your account. I have signed into my code.org account. I've already set up my dashboard, as I believe you have as well. And you can see that I have Course D listed in my dashboard. I can just click it and I can scroll down, and we've already done lesson 3. So today I'm going to demonstrate lesson 5, debugging with Laurel. So I'm going to go to lesson 5, debugging with Laurel. I'm going to click on 1. The first learning module is a video about debugging, which I encourage you to watch, but we're going to skip it for now. I'm actually going to start you with lesson 2. So we have Laurel here. And Laurel has to step and collect jewels. So what we want to talk about is what happened, what was supposed to happen, and what does that tell you. So remember, the objective isn't really to see who can move Laurel through and pick up the jewels the fastest, although it's great if they can do that. We want students to be able to unpack these computer coding constructs. So let's develop a plan, a problem-solving plan. Let's see what happens when I click run. Oh, whoa. Laurel got there really quickly. If this were a race, I think Laurel would win. But I don't think that Laurel's objective is to get to the end very quickly. What is her objective? Her objective is supposed to pick up the jewels. So what happened? Laurel ran right past all the jewels. What was supposed to happen? Laurel was supposed to stop and collect the jewels. So now, what do I need to do? What does this tell me? So because Laurel's not collecting the jewels, watching this tells me that Laurel needs to stop and collect the jewels. But you know, I'm going to use the step feature, and I'm going to walk her through step by step. She's moving forward, she's moving forward, and she's moving forward. I'm going to reset this. So, oh no, I see a problem. Let's read the instructions. It's important to read instructions. I'm going to run, move forward, collect a jewel. Move forward, collect a jewel. Move forward and collect a jewel. Now let's try running it. Again, I don't want students to stop here. I want them to replay it. Yes, Laurel collected all the jewels, but in life there's never just one way to do something, is there? There's always multiple ways. Some are better. What makes one thing better than the other? Let's look at it. What was supposed to happen? I'm going to show the code here. Here's my code. I move forward, I collected, I move forward, I collected, I move forward, I collected. That makes sense. That's what Laurel did. Do I see a pattern here? Is there a sequence of things that are happening? And I do. I notice 1, 2, 3 repetitions. So I'm going to try to write this code in another way. I'm going to reset. So let's see, Laurel moves forward, collects, move forward, collects, move forward, collects 3 times. So I need to put a 3 in the box. And now I'll run it. Awesome. Look what happens when I show the code for this. Now this is the code for what I have written, but this down here, that's this unused code. So it confounds things if students don't throw their unused code from the workspace into the tool space. Now I can show the code again, and I'm only going to see the code for what I am using and not all that noise in the background. So this means we're going from 0 and we're stopping at 3. So there's 3 repetitions. She's going to move forward. She's going to collect. It makes a lot of sense. So I would have students work through the next couple of puzzles on their own. Let's go to 3. It's very similar. Remember that this is your code, it's a algorithm, and it's also a program because it's a list of steps meant to be run by the computer. All right, so we'll do 3 on their own, but we can debrief. Look at it. Run it. They have to debug it. They have to fix it. Let's ask them, how many lines of code did you use? Who used the least? Who used the most? Did somebody use the repeat button? Was there a pattern? Go on to lesson number 4. Again, can we look at this and can we see a pattern? Run, reset, use the step button. Uh-oh. I don't think she needs to move forward. Let's get rid of those. Reset. Try again. Let's get rid of the unused code now that I know I don't need it. Let's keep our workspace clean. Do I see something that can be changed? I do. I see a pattern. We have 3 collects. I'm going to change it to collect. I'm going to throw away my stuff. I'm going to reset it, and I'm going to go. All right, let's skip to 4. You're going to have them do some on their own. They're going to do 4, 5, 6. Let's go to 7. And what happens when you get to 7 is this lovely thing is going to pop up, and it's going to be a challenge puzzle. And yes, of course you're ready. You never skip the challenge puzzle. Let's start by having kids use their critical thinking skill of observation. Wow, what do you notice? There's code written for you. Hopefully they notice there's code in my workspace that I didn't put there, and it's not even connected yet. Why do we think it's there? Do we think code.org means for us to use it? Do they not mean for us to use it? What am I going to do with this? So as we look through this, this is kind of a complicated grid. It might be good to just see what happens first. We're developing problem-solving strategies before they jump in and start trying to fix this. Observe the workspace and see what happens when you hit run. So that was successful, right? Laurel moved forward and she collected the jewels. Where do I want her to go next? Let's make a plan. I want her to go left. I want her to turn left again. I want her to collect 2 jewels. I've got all this code in the workspace. Let's see if we should move it. This works. I'm going to have Laurel turn left. I'm going to have her move forward. I'm going to have her turn left again. I'm going to have her move forward. And then I'm going to have her collect 2 gems. Now I could continue on if that's my plan with the whole entire puzzle, but it might be nice to stop and just sort of assess if I have any bugs in my program, because it's easier to fix the bugs right away. I'm going to reset this and I'm going to run my program. Looking good so far. Now, move forward 1, move forward 2. Turn left again. 1, 2, left. Move forward 2 more spaces. And collect 2 jewels. Again, I'm going to reset and I'm going to run it. So far, so good. I think I want Laurel to move forward 1 more time. I'm going to have her turn left 1 more time. I'm going to have her move forward. And I'm going to have her collect the 2 jewels. Now what you can do once the students get to this point is to see, do we see anything repeating? Is there a loop? Remember that if I see a pattern and something's repeating, I have created a loop. So that's the challenge puzzle. And then I'm going to have you go to 9. They can do 8 on their own. When they go to 9, this might be a really great time to have your students work collaboratively. Let's look at this puzzle, and rather than just having Laurel successfully collect all the gems, let's have the students come up with 3 different ways that Laurel can navigate the play area and collect all of the jewels. By the way, how many jewels does Laurel have to collect? There's 5 here, and there's 5 here. Laurel has to collect 10 jewels. So these are just some things that you can do with your students, and in a minute I'll debrief the strategies that we used. So in this video, or in this lesson, we used decomposition. We broke a big task down into smaller tasks. We debugged programs. We were given instructions, and we had to find what was wrong and fix it. We used our repeat button. We noticed that actions were happening over and over. We looked for a sequence, and we saw a pattern, and we created a loop. We wrote an algorithm, but it was a program because our algorithm was specifically supposed to be run by a machine. So we created programs. Critical thinking skills that we use today. We compared the code to the blocks. What happens when we do something one way? What happens when we do something another way? We looked at cause and effects. We made a plan. How are we going to get Laurel through this maze? How are we going to get rid of the bugs? I didn't predict, but you can easily say, what do you think is going to happen when I press this button? Is this program going to work? Is it not going to work? We made observations. Let's observe what happens when we press run. What happens when we press step by step? Why do we think there's extra code in our workspace that's not being used? we solved problems and we created sequencing and we recognized patterns, pedagogical skills that we used. We gave students time to think and play and explore on their own while we circulated. We provided direct formative instruction. We used the PRIM model. Let's predict, run this, let's investigate, modify, which is debug, make a program, create an algorithm. We help students to understand what the problems were, to devise solutions, and to transform the solution into a programming language for execution. Next video I'll be doing is 8 Dance Party.